Hey everyone, in this video we'll be solving quadratic word problems involving geometry part 2. These questions are going to involve uniform width and some more complex setups. Our first example, an artist is trimming a piece of paper that has dimensions 18 inches by 12 inches to frame his latest picture. If he wants to trim each side by the same amount so that the area of the paper will be 135 square inches, how many inches must he trim from each side? So to visualize this, let's start by drawing the original piece of paper, which is a rectangle with dimensions 18 inches and 12 inches. These can be switched and the problem would be the same. Now he's going to trim the same amount from each side. So he's going to wind up with is a smaller rectangle. Now he's cutting the same amount from each side. So let's say that he cut X inches from this side and X inches from that side. So we'll let X be equal to the width of the trimmed section. Okay, so then to find the dimensions of the new rectangle, well, the length was 18 inches and we took a section of X inches off. So the new length would be 18 minus X. The width was 12 inches, but we cut a section of X inches off, so the new width would be 12 minus X. So to find the area of this smaller rectangle, we're going to multiply the length by the width, so 18 minus X times 12 minus X, and we're going to get 135 square inches as the area. So now we have our equation. We can distribute. So we have 18 times 12, which will give us 216, minus 18x minus 12x plus x squared equals 135. Combining our like terms and writing it in standard form, we'd have x squared minus 30x plus 216 equals 135. Now we'll have x squared minus 30x plus 81 equals 0. Right? We have a quadratic, so it has to be equal to 0 in order for us to solve. So let's see, can we think of factors of 81 that add up to negative 30? So that would be negative 27 and negative 3. So we have x minus 27 or x minus 3 equals 0. So we'd have either x equals 27 or x equals 3. Now, in the context of this problem, he can't cut 27 inches from a picture that only has dimensions of 18 inches and 12 inches. So that answer doesn't make sense in this problem. Let's fix that. So x equals 3 is the amount of inches that he must trim from each side. So 3 inches. Perfect. Next up, a landscape architect is designing a garden for the new town park. In the original design, the length of the garden was 5 feet longer than its width. In the revised design, she doubled the length of the garden and decreased the width by 5 feet. If the area of the revised garden is 50% larger than the area of the original, what are the dimensions of the revised garden? Okay, so a lot to take in here. Let's start with the original design. Okay, so we have a rectangle to represent the original design, where the length of the garden was 5 feet longer than its width. Okay, so the width is x, and then the length is x plus 5. Okay. Then she revised the design, so we have some new rectangle, not necessarily drawn to scale. She doubled the length, okay, so she doubled the side length of x plus 5, and she decreased the width by 5, so x minus 5. Now the area of the revised garden is 50% larger than the area of the original. Okay, so let's find the areas and define the let statement. So we'll let x be equal to the width of the original. And then we have x plus 5, 2 times x plus 5, and x minus 5. But we can leave those in the diagram. Okay, so the area of the original design, all right, area, would be x times x plus 5. The area of the revised design is 2 times x plus 5 times x minus 5. It's saying that the area of the revised garden is 50% larger. So that means if we multiply the area of the original by 1.5, we get the new area. Okay, so let's use that to set up our equation. So 1.5 x times x plus 5 equals 2 times x plus 5 times x minus 5. Right, and just to understand 1.5, if we multiplied it by 1, that would be exactly the same area. 1.5, we've made it 50% larger. Right, we added half of the original area onto it. Okay, so we have 1.5 x squared plus 7.5x, and that's going to be equal to 2 times x squared minus 5x plus 5x minus 25. Middle two terms simplify, and we can distribute the 2, so we have 1.5x squared plus 7.5x equals 2x squared minus 50. Now, we do have a quadratic equation, so we need to move every term to one side. So let's move these two terms to the right, so we'd have 0 equals 0.5x squared minus 7.5x minus 50. And I'd rather the equal 0 on the other side, so let's 0.5x squared minus 7.5x minus 50 equals 0. All we did, move the equal 0 over. Now I don't really want to factor with decimals, so let's multiply this whole equation by 2. Now I could multiply by 10, but I have 0.5s here, so multiplying by 2 will keep my coefficients small. So that's going to give me x squared minus 15x minus 100 equals 0. So now we can try to factor, so we'd have x and x, so we need factors of negative 100 that add to negative 15. So that's negative 20 and positive 5. So either x minus 20 equals 0, or x plus 5 equals 0. So that means either x equals 20, or x equals negative 5. Now, context of the problem, negative 5 does not make sense. So x equals 20. Now let's go all the way back up to the word problem. What are the dimensions of the revised garden? Okay, so remember, x equals 20. So here, we'd have 20 minus 5, so we have 15. And here we'd have 20 plus 5, which is 25, times 2, which would be 50. So the dimensions, and what units are we dealing with? Feet. So the dimensions are 15 feet by 50 feet. Hey, so that one took a little bit of work, right? Especially the equation with that 1.5, we're not used to seeing that, right? But 50% larger, we'll multiply it by 1.5 and a value would be 50% larger. And then from there, it's just keeping track of all of our values. Don't really want to work with decimals. Okay, so you could have multiplied everything by 10 or by 2, as we did in this example, and then finish by factoring and solving. Okay, but a good picture really helped us out here as well. The blacktop at the local elementary school currently has a length of 120 feet and a width of 100 feet. The school plans to increase both the length and the width by the same amount to create a blacktop area that is 62% larger than the original area. Determine how many feet each side will be increased to the nearest tenth. Okay, so we have a blacktop area currently with dimensions of 100 and 120. Now we're going to add to both the length and the width by the same amount to create this new blacktop area. Okay, so let's say we add x here and we add x there. So the new dimensions, this is going to be 120 plus x, and this is going to be 100 plus x. So let x be equal to the increase in length and width. Okay, so it says the area of the new blacktop area is 62% larger than the original area. Okay, so the area of the original piece is 120 times 100, and the area of the new blacktop is 120 plus x times 100 plus x. And this new area is going to be 62% larger than this area. So 62% is 0.62, but larger means 1.62. So for our equation, we'd have 1.62 times 120 times 100 equals 120 plus x times 100 plus x. So now let's go to our calculator. So (1.62) times 120 times 100 is 19,440. And we're going to distribute here. So we're going to have 12,000 plus 120x plus 100x plus x squared. So combining our like terms, we have 19,440 equals 12,000 plus 220x plus x squared. Now we need to equal 0 because it's a quadratic, but I'm going to switch the sides. I'm going to move here so we have x squared plus 220x, and then we have minus 7,440 equals 0. Okay, so I subtracted the 19,440. That doesn't look. But I wrote everything on the left side of the equal sign, okay, just to save us a step. Now, they did say round to the nearest tenth. So that tells me that I'm probably not going to be able to factor this quadratic. So let's start with the quadratic formula. Even if it could have been factored, we would find the answer. So we have a equals 1, b equals 220, c equals negative 7,440, and our discriminant, well, we're going to need a little help here. So that's 220 squared minus 4 times 1 times negative 7,440. Okay, so let's go to the calculator. So we have 220 squared and then plus 4 times 1 times 7,440. I took into account negative times negative is already a positive. So that's 78,160. Okay, so now we can go to the quadratic formula. So x equals negative b, negative 220, plus or minus the square root of the discriminant, which is 78,160, over 2a. So if we split this up, either x equals negative 220 plus the square root of 78,160 over 2, or x equals negative 220 minus the square root of 78,160 over 2. Now, negative minus something is going to be negative in the context of this problem. Doesn't make sense. So we need to figure out what this value is. So as we did in the previous video, let's figure out the numerator first and then divide by 2. So negative 220 plus the square root of 78,160 and then we're going to divide that value by 2. So 29.78555. So x equals 29.78555. Let's just make sure I had that correct. There we go. Now we're rounding to the nearest tenth, so x is 29.8. Now what are we looking for? We're looking for how many feet each side will be increased to the nearest tenth. So 29.8 feet. Okay, so the setup here, we had another percentage increase, right? So we had to account for that with that 1.62. And in this case, we had a quadratic that we couldn't factor, so we had to use the quadratic formula. And it definitely took some time, right? We had a decent amount of work for this single problem. Moving on. Mr. Jones was given a class picture in a nice frame to hang in his classroom. The dimensions of the picture are 8 inches by 11 inches, and the total area of the picture and frame combined is 180 square inches. If the frame has the same width on each side of the picture, what is the width of the frame? Okay, so let's imagine we have a picture frame with a picture inside. So the dimensions of the picture are 8 inches by 11 inches. So 11 and 8. That's the dimensions of that inner rectangle. Now the frame has a uniform width. So let's define that width as x. Okay, so our let statement, x is the width of the frame. Okay, so the length of the picture was 11, but we're adding x inches on both sides. So the dimension of the frame is 2x plus 11. And then the width of the picture was 8, but we're adding x on each side. So the width of the frame is 2x plus 8. Now, the area of the picture frame with the picture inside is 2x plus 11 times 2x plus 8. And the combined area is 180 square inches. So here's our equation, and we can start solving by distributing the left side. So we have 4x squared plus 16x plus 22x plus 88 equals 180. So we have 4x squared plus 38x plus 88 equals 180. 4x squared plus 38x minus 92 equals 0. Now we can take a GCF of 2 out. So we'd have 2x squared plus 19x minus 46 equals 0. So we'd have 2 times 2x and x equals 0. So can we think of factors of negative 46 that if we distribute out would give us positive 19? So let's see. If we had 2, would it be 2 and 23? Let's try that. 2 and 23. So we have 23x and 4x. Well, if that was a negative 4 and that was a positive 23, that would be perfect. All right, I got it on the first shot. Not always going to happen, and you definitely could use grouping here. You'd multiply 2 times negative 46 and get negative 92. Come up with the factors of negative 92 that add up to 19, and then go with grouping. But since we got it using the guess and check method, we set each factor equal to 0. So here we'd have x equals negative 23 over 2. Here we'd have x equals 2. Now 2 doesn't equal 0, so that's out. We're adding a width around a picture, so it can't be negative, so we reject that answer. And x equals 2 is our solution, but let's go back to the problem. What is the width of the frame? Okay, so the width of the frame is 2 inches. Okay, so this is your uniform width type problem. Now, it could be a picture frame, could be a garden with a walkway around it, whatever the case might be, a picture is really helpful. Okay, and understanding that the uniform width means we're adding the same thing on either side, create new dimensions to create our equation. Last problem. A rectangular turf field is going to have a uniform walkway of 8 feet built around it. The length of the turf field is 10 feet longer than its width. If the total area of the walkway and turf field combined will be 3,696 square feet, determine the dimensions of the turf field. Okay, so we have a turf field, and we have a walkway around it. And they tell us the walkway is 8 feet. So we know the dimensions, or the width of the walkway is 8. And it says the length of the turf field is 10 feet longer than its width. So if x is the width, x plus 10 is the length. So we'll let x be the width, then x plus 10 is the length. So the dimensions of the combined field and walkway, so the length, we have x plus 10 for the field, 8 and 8 on each side, so we have to add 16. So that would be x plus 26. And then for the width, x for the field, 8 and 8 on either side, so x plus 16. So to find the area, multiply the length by the width, and that's going to be 3,696. So we distribute on the left side, so we have x squared plus 16x plus 26x plus 26 times 16, which is 416. Combine our like terms, so x squared plus 42x plus 416 equals 3,696. We need the equation equal to 0 because it's a quadratic. So we subtract 3,696 minus 3,280 equals 0. Okay, so now we need to come up with factors of 3,280 that add to 42. Okay, so let's see. If we divide 3,280 divided by 20, we have 164, so that wouldn't work. What about 3,280 divided by 40? Let's increase it a little bit. 82. Well, one of those values would have to be negative, right? Either the 40 or the 82, and that would give me 42. Okay, so we got it on the second shot. So our factors are x minus 40 and x plus 82. So that means either x minus 40 equals 0 or x plus 82 equals 0. So either x equals 40 or x equals negative 82. The negative answer for x doesn't make sense here. So x equals 40, and they're asking for the dimensions of the turf field. And what are we dealing with? We're dealing with feet. So we have 40 feet for the width, and x plus 10, so 50 feet for the length. Okay, so these geometry problems were definitely a little bit more involved. They required us to either take a uniform value away, or add it to, or put it around the whole rectangular region in uniform width, right? Whether it was a frame, or in this case a walkway, and then proceed from there. Add to that the percentage increase problems, right, where we took an area, an original area, and we increased it by a certain percentage. Those are the problems that we focused on in this video. And the only way to really understand these is to try a few on your own and work on that setup. If you can get this setup, I'm confident that you're going to be able to solve the quadratic that you wind up with. Worst case scenario, you use the quadratic formula. But it's all about the setup. Draw a good picture, define a let statement, and work on setting up as many of these as you can. And then finish a few off to make sure that you get the correct answer. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.